Anthony, do you mind reading the objective for today?
I can do that. 5.4 sum and difference formulas. Today I can use sum and difference formulas to evaluate trig functions as shown by the exit ticket.
Yep. So if that tells you anything, we're going to be doing sum and difference, which is on the little handout that I gave you. And as well as there will be an exit ticket that you'll turn into me, because I'll need that for my class. So this is basically just on your handout. And if you need a few minutes just to write this down, or if you just want to keep your sheet, that's perfectly fine. So, and you might be asking, what's the U and V? Well, say we have sine of 150. Obviously, that's not on our unit circle, so we'll try to break up that 150 to be two sums or two differences that we do know. So, if it's sine, how best to remember this is that with sine, the sign in the middle stays the same. It's addition here, it's addition here, it's subtraction here, it's subtraction here. For cosine, opposite of that. So it's adding U and V, it's subtracting in the formula. If it's subtracting, then it's adding. It just does the opposite for cosine. For tangent, if it's addition, the sign's going to stay the same on top, change on the bottom with 1. Yes. And for tangent, we have tan U plus tan V over 1 minus both of those multiplied together. Okay. Let's go into an example. So, sine of 75 isn't one that we necessarily know. I mean, we could try to find it using our calculators, we could try to find OKs between this. It's about in between here. But there's a simpler way to find that. Can anyone think of a sum or a difference of two numbers that we do know to give us that 75? Anthony?
You could do 45 plus 30, which would equal 75.
You can. So you said 30 to 45? Yeah. And it can go either way. You can have 45 first or 30. The order doesn't matter because it's addition. Or it will matter for subtraction, obviously, because it's not the same thing. So, for sine, since it's addition, which one are we going to use? Can someone read that out to me? Someone other than Anthony. So sine of u, cosine v, is that what you said?
Yep.
Plus, remember sine stays the same. Finish it.
Cosine u, sine v.
Alright. So our u, if we write this as an equation, because we want this to be an equation, it would be sine of u plus v, right, equals this, so equals. We want the sine u plus v in front of that. Or in other words, this sine u plus v will change into what we have over here since we're splitting that 75. So we're going to let sine of our u is going to be 30 plus our v is going to turn into 45. I apologize for my handwriting in advance. So now that we have our u, we have our v, we can now plug into this equation. So, as an equation, we're going to add the equal sign here. So sine of 30 plus 45 plus, sine stays the same, cosine of 30 this time, since we're switching u and v, cosine of 30, sine of 45. You guys can kind of write this down? Am I going too fast? Okay. Yes.
I wrote it as 45 plus 30.
That's completely fine.
Doesn't matter.
It doesn't matter. It will matter, as I said before, it will matter when it comes to subtraction. Because 30 minus 45 is not the same as 45 minus 30. You'll get a negative there, and we don't want to work with figures. So, so rewriting this, I'm just gonna come down here. So it's sine of 30. I don't know my municipal, someone tell me. Sine of 30.
Mrs. Custer's favorite.
Mrs. Custer's favorite. So we have 1/2. Cosine of 45. Root 2 over 2. Plus cosine of 30. Root 3 over 2. Sine of 45. Root 2 over 2. Where's what fraction? It's always fun, isn't it? What's 1/2 times root 2 over 2? Root 2 over 4. Oops. Wrong one, you're fine. What's root 3 over 2 times root 2 over 2? I'm hearing a lot of different answers.
So you root 6 over 4.
How'd you get that?
So you multiply root 3 and root 2, and since they have a common thing in the square root, you can just multiply the 2 together, which gives you 6, and then it's all underneath the square root.
So they don't have the same thing. I'm not sure what the thing you're referring to, but they're both square roots. You can multiply a square root times a square root. You can just multiply
Honestly,
those
I don't
numbers
even know.
together. That's okay. So you're right. It should be root 6.
Yeah, that's what I was
Over
thinking.
4.
They have the same root.
Are we done? We have a common denominator. So what's the final answer? Yeah. Root 2 plus root 6. That.
You can take them. They've just been projects.
All over 4. What questions do you have so far? None? We're good to go on? Okay. Yes, put it down. Make sure you sign it. Yeah, there should be. Alright. This one's on you guys. Well, let's at least get started together. So cosine of 15, we can't really take an addition here because we don't have anything that we know that adds together to get 15 other than negative numbers. But like I said, we don't want to work with negative numbers. So this kind of gets in your head like this is less than 30. That's because that's the lowest one other than 0 that you know. So 30 is going to be a part of it. You want to say that out loud, Mark? 45 minus 30. So, so this is going to change into cosine of 45 minus 30. You guys do the rest. Your calculator. You're working on it via calculator.
Oh, I was just seeing something.
minus because we're minusing, and since it's.
You mean
wait,
subtracting?
Cosine is plus.
Oh, it's
Cosine changes sign.
Well, no, I thought we were doing sine.
That's my bad.
That's okay, that's okay. So cosine, if it's minus inside the parentheses here, it's gonna be addition on this side.
No, I did sine and not cosine.
Also cosines, for cosines stay together, sines stay together, whereas in sine, it's sine, cosine, sine. Any questions? Are you saying just push them up front? Keep going. Okay. We're gonna get a little more difficult, is that okay? A little harder? You guys are gonna love it. I should do that this way. Now we're working with 13 pi over 12. We have a pi in there this time. What do you guys think? Ignore the 12 on the bottom. Just list two numbers that get you to 13. There's 1 and 12, 9 and 4. There's, you can go forever. You want to use 9 and 4? Let's use 9 and 4. You're actually right, by the way. So, if we have 13 pi over 12, we're going to say that's 9 pi over 12 plus 4 over 12. Or 4 pi over 12, sorry. What do you notice about those fractions? Not perfect squares. Well, 9 and 4, yes. They can be simplified into what? I was like,
3 pi over 4 and 2 pi over 2.
not 2 pi over 3.
Oh, pi over 3.
Just pi over 3. Is that hard to read in the back? Sorry, I'm writing a little small. No? Okay. So let's rewrite this. So you have cosine, make sure it's cosine. Cosine of, does it matter which order? Yeah. So we're gonna have 3 pi over 4 plus pi over 3. And since it's addition, since it is addition on each side of the parentheses, it's going to be what on the right side? Subtraction. So cosine stay together. So cosine of u, which is 3 pi over 4, times cosine of v, which is pi over 3. I'm running out of room. Plus sine of u, which is 3 pi over 4, sine of v, which is pi over 3. Now, I don't have a music circle in front of me. That is my fault. I didn't have it memorized all through college. Thank you. Thank you for catching that. It should be minus sign. That was my fault. Thank you for catching it. See, even teachers make mistakes. Alright, so it's cosine 3 pi over 4. So, root 2 over 2. It would be, thank you. Cosine pi over 3? Alright, what happened? Sorry, if you see me write this little dot here, that means multiplying. That's how I've learned to write multiplication, is just with a little dot. because when you work with variables, x kind of looks like the multiplication sign, and it's supposed to be a variable. So, minus, thank you for catching it earlier, sine 3 pi over 4. Say that loud, Mark. Root 2? Is that what you said? Root 2 over 2. Times sine pi over 3. Root 3 over 2. Now we're in the easy bit. We're in the long run. You got it all right now. Now it's just multiplying and subtracting fractions. Lovely. So what's this first one? Negative root 2 over 2 times 1/2. Negative root 2 over 4. Minus, got this wrong before. Root 6 over 4. We're just working with the same numbers, aren't we? So, common denominator, and you could switch this, although it's the same. We have minus root 2, or negative root 2 minus root 6, all over 4. What questions do you have for me so far? None? Everyone feel the same? Okay. You guys got this one. So you have sine 52 cosine 22 minus cosine 52 sine 22. Now you don't have to split all of it up because it should look kind of familiar. Look on your sheets or in your notes. There's a sum and difference formula that matches that. And the degrees match. 52, 22, 52, 22. And guess what? There's our U, there's our V. Alright, so what formula does this match? I mean, I can tell it's going to be a sine, because cosine, same three functions together. So sine of U and V on minus, because it matches the sine. What's our U and V? So sine of 52 minus 22. Are we done? Nope. We're not done yet. So it's going to be sine what's 52 minus 22? 30. Are we done? No. What's sine of 30? 1/2. Now you're done. Does this make sense where we got the U and V from, how we knew it was sine? I think you're lying now. Alright. You guys can do one on your own? Do you have a question, Mark? No? You're just waiting by like 5? Oh. Will be waiting then? No, she wasn't. I believe her. This one's a little harder. Just a little. So sine of U equals negative 7 over 25, and cosine of V is negative 4 over 5. All you have to do is just solve it. What's one thing you know about sine? Think a little farther back. What is sine? It's the y value. I don't know if you really want to be looking for an arc sine of negative 7 over 25 to find u. You can. hypotenuse. All you have to do is find that missing side. So, let's set up a triangle for sine of u. So, we're in quadrant 3. So that's this one. We're down here. We're over here. So we're gonna go -7. So there's 7. Down 25. I'm gonna say that's here. It's not. Don't quote me on it. So we're just gonna go here, here. That side's 7. This side's 25. So, yeah. That's bigger side. Because this is, you're starting from the 0, that's your angle. That's your angle of depression. So, you guys work it out. What's this missing side? This is so easy. What's this side here? Negative what? Not negative 20. We'll check that. Negative 24. Okay. Let's do the V next.
How do you make, oh,
It's Pythagorean theorem.
this.
You have the opposite side, you have to do, or blah. A squared plus B squared, we didn't know the B squared, equals C squared. 25 times 25, I can't list that number in my head. -7 times -7 is just 49. That's how, and then you square root it, that's how you got the -24. The reason why it's -24 is because we're going to the left.
Yeah, it's just, I'm trying to figure out how then it shrinks down to -4/5 if it's -24.
Different angle.
Well, I mean, yeah, but it's cosine of that one angle there. And so that means that it has to be, unless you're talking about it,
It's a different angle, so it could be 30 degrees, it could be 60 degrees. Could be anything.
So this is our angle that we're working with. Our hypotenuse is going to be 5 this time. And our adjacent, if this is our angle, which sides are adjacent? Is it this side or this side?
it's
The top. This one should be super easy.
3
It's Pythagorean triple. It's not just 3
or
going down.
-3.
-3. Don't get your signs.
Yeah.
So now, what you can do
Oh.
is now remember u and your v, but now it's cosine. So that's the adjacent over hypotenuse.
I remember when we talked about this.
So we have cosine of u plus v. Okay? Sorry. And it's going to be cosine of u times cosine of v, correct? Because cosine and the cosine stay together, the sine stay together with the change sign in the middle. So it's going to be cosine of u, but we weren't given cosine of u. But now we have all 3 sides, we can find cosine of u. Cosine of u is what over what? -24/25. That's the adjacent side over the hypotenuse. Cosine of v, we were given -4/5. Here 5. It's adding, so we are subtracting. I'm gonna run out of room again. I need to write small. Okay. So now we have sine. Is it v first? No, it's v first. Sine of u we were given. That was -7/25 times sine of v. What's sine of v? That's my fault. So originally, it's supposed to say the actual function here, the actual formula that you have. And with the cosine of u, that's what you have here. Cosine of v, sine of v, sine of v. That is my fault. I'm so sorry. So,
Those are the answers to.
those are the answers to those.
Oh.
So, hang on. Let me get back up there. Hang on. I know I'm a little confusing, but that's just because I messed up. That was my fault. I can. Oh, now I'm happy. No stick. Okay, don't put that in. I'm sorry about it. That was my fault. I'm so sorry. So we have cosine of u, cosine of v, minus sine of u, sine of v. So we said cosine of u was negative 24 over 25 times cosine of v, which was given, then negative 4 over 5. Did I write that right? Cosine of v was negative 4 over 5. Minus sine of u, that wasn't given. That wasn't given. Sorry guys, this is what it should be. My fault. I am so sorry. Okay. Continuing on from here. Yes, yeah, you can use your calculators. What's negative 24 times negative 4? 96. Remember, negative and negative makes it positive. 25 times 5? 125. Minus negative 7 times negative 3? 21 over 125. Do you want to combine them now at the top over all 25 or just solve it? Alright. Those seven combine at the top.
Oh. I didn't know you meant that.
What's 96 minus 21?
75.
75. Are we done? What's next? 75. What does it simplify to?
3/5.
I have to get 3/5.
Divide both the numerator and denominator by 25 or factor it out.
Now we'll be done. Now we're done. Here's your answer. I'm so sorry for earlier. Alright, there's your exit ticket. You are turning this one in. You have a formula sheet for tangents. You are turning these in to me. Yes, you have to turn it in. It's an exit ticket. It's like a train station. You can't leave without giving the conductor a ticket.
Hi.
Good.